Today we're going to be doing sine law. Now, lots of people get stressed out when they see a proof. In the end, you're going to have to memorize this formula and or this formula. Both of them will work. And if you don't understand the proof, don't stress too much because you need to memorize the end result. So let's take a look at our triangle first. We've set up a triangle that isn't a right angle. That's why we have the sine law, so we can do things with triangles without right angles. So if we look at this one, we have triangle A, B, C, and we labeled this here D. You're going to have to add this in. This should be a right angle. And if we look at the side lengths across from lowercase a is little a, side, and across from the angle capital C, right across will be lowercase c, and across from capital angle B will be lowercase b. All triangles work like this. Across from the capital letter angle is the lowercase side. And if we look, we guide you through here. In triangle ABD, we have sine of B, which will be opposite over hypotenuse. They've labeled this H for height, not for hypotenuse. So again, sine B, sine of angle B, opposite over hypotenuse. And we get this right here, and we just solve for H. And then we look at in triangle ACD, we are dealing with sine of angle C, which will be opposite over hypotenuse. And again, rearranging, bring the B up here, we get this expression. And if you look, we have H equals this, H equals this. Well, those H's have to be the same, so that means that this must equal this. And if you rearrange it, you can get this expression. So we just bring this C over to the other side and it'll be divide, likewise with the B. And we can do the same process to solve for, or to show that sine of angle A over A, little a, and sine of capital B over little b. We were not going to go through that. And therefore, in any triangle, we get the sine law, which is this right here. So sine of the angle over its opposite side is equal to sine of the other angle over an opposite side equals the sine of the last angle over the opposite side. And you can flip this whole thing and it'll still be true. So those are the two sine laws that you can memorize. But if you're not comfortable with memorizing both of them, you can just use one of them the whole time and it'll still work the same way. When to use the sine law? The sine law is used when there's first no right angle. If there is a right angle, you're going to use SOHCAHTOA. If there's no right angle, then you have to decide between the sine law and then tomorrow's lesson, the cosine law. So let's talk about the sine law. You have two ways to remember this. There's no right angle, and if you're given two angles and a side, then you can use the sine law because you can always figure out the third angle because they all add up to 180. The other option is two sides and a corresponding angle. So what that means is two sides and a corresponding angle. So if you're given this side here, right here, then the corresponding angle will be the one straight across from it. So this angle right here. But it would also work with this side here and straight across, giving you this one as well. Now there's a third option that I like the best, so I'm going to circle it. When you know an angle and an opposite side and no right angle. If you know that, if you know an angle and an opposite side, you can use sine law every time. Now make sure there's no right angle, because if there's a right angle, then you'd be using SOHCAHTOA. So again, I'll show you on the next two examples how it is the sine law, but of course this is the sine law lesson, so you know for sure today is going to be dealing with sine law. But then tomorrow you'll see why I did that so that you can compare it with when you're going to be using the cosine law. So let's move to the next slide. So we have two questions to do here. So let's do A first. So if we look here, we have two angles right here, and we have a side length. Whenever I'm given two angles in a triangle, I automatically go and figure out the third one, and I just write it right in there. You can show the work right here. How did I get that? I did 180 minus 50 minus 44 because they all add up to 180, and I just wrote it there. But I always do that because lots of people look at this question and don't see that it's a sine law because they say, oh, I have a side, oh, I don't know the opposite angle, so I'm not using sine law, but you can figure it out. Anytime you're given two angles, you can find the third. You might not have to use it, but it's good practice to just fill it in right away. If you don't use it, that's okay. And now if we look, I seldom write out the formula because it's great if you're given the triangle ABC, but what happens if it switches to X, Y, Z, or they don't even label it? So I sub directly into the formula, and the way it works is they want us to solve this triangle. That means I have to go and find every single side in this case, so I'm going to go and figure out the formula. So if you look at the formula, it's always paired up with a side over the sine of the opposite angle. Now, there are three parts to this, but usually you're only going to use two at one time. So right now, we're going to forget about one of them, and in this case, it's going to be this one. And if you look at how it matches up, we get the side 10 over the sine of the opposite angle. So we wrote that right here, just subbing it directly into the formula. And then pick the other angle that you want to work with. So we're going to be working with the angle 50 so that we can go and look for the opposite side, which is lowercase b. So we're going to go and do little b over the opposite sine of the angle. And we wrote that right here. This sine of 50 is going to move to the other side, so it'll come up. Since it was divided by b here, it's going to move over and be multiplied with the 10. You can punch that entire thing on your calculator. You'll get this decimal, and in this unit we round to the nearest one decimal place. Do not forget your units. The next one we're going to do is we're going to solve for lowercase c. So right here, we need to find that angle. When it says solve the triangle, you have to find everything. So at this point, we're going to be dealing with, we're going to go back to the original A and sine A because we were given the 10. Always try and go back to the information that was given to you, and we were given the 10, and that will be 10 over sine of 86. So we got that right here. And then we are going to be looking at the c that we want to find, lowercase c, and that will be over the sine of 40 degrees. So that's, 44 degrees, sitting right there. So you'll notice this time we did not use the middle portion of our sine formula. And then it's solved very similarly. So we end up taking the sine of 44. It was divided by c on this side. It will move up and multiply with the 10, and you end up getting 7.0 centimeters. Now you can always do a quick check. In triangles, across from the biggest angle should be the biggest side, and across from the smallest angle should be the smallest side. So you can do a super quick check. It's not 100% that you'll be finding all your errors, but if you look across from 86 degrees, we have the biggest side 10 centimeters, and across from 44 degrees, we have the side length of 7, which is the smallest side matching with the smallest angle. So we should be good. Now some people ask, when should we use this form of the sine law, and when should we use the other form, which it looks like this. Usually we like to put our unknowns in the numerator, so in the top. So if you look, we're going to be trying to find angle D and angle E in this question. So we're going to use this form of the sine law. It just makes rearranging a little quicker, but if you decide to always use this form, you'll just end up cross-multiplying and still solving the same way. So we are going to be using the sine law for part B because I know an angle and its opposite side. Since I'm solving for, it's going to be D or E first, I'm going to use this form of the sine law. And we start off with what we know. So we know sine of 35 degrees over the opposite side, which is 30. So I wrote that right here. We're going to go and solve for D next. So we get sine of D over the opposite side, 50, and we get that right here. Now the 50 is going to move over to the other side and be multiplied. This you can calculate to be a decimal, which is right here, and then you take the sine over and do sine inverse, and you get 73 degrees, and we round to the nearest degree because it's an angle. So we just went and figured out what D was, so let's go and figure out what the last side was, the last angle. So it's going to be 180 minus the two angles that we know. So we're going to take 180 minus 35 minus the 73 we just found, leaving us with 72 for E. And let's write that in. So then I can go back to my sine law, and we're going to finish this off and find the last side length. So since I'm finding the side length, I'm going to be using this form of the sine law, where the side length is on the in the numerator. So again, I start with the original stuff I was given. I get 30 over sine of 35. I want to find out what little e is, which is right here. So I'm going to get E over sine of 72 degrees, sitting right here. Take the sine of 72 to the other side, it'll be multiplied, and punch it in on your calculator, round to 1 decimal place. I think that covers it. So tomorrow's going to be a pretty straightforward for homework. You're going to get a bunch of questions that find angles and sides in using the sine law. Again, when you start your homework, you should be using these examples as a model so that you're following all the correct steps. And then halfway through, hopefully you can switch over and you remember the process and you don't need the notes anymore. But it's imperative that you look at the notes as you're doing the first few questions, because these are the steps we expect to see, and when we don't see them, people end up losing marks. Have a good night.